Well, hello everyone, and welcome to this Austmine webinar on supply opportunities in New Caledonia's nickel sector. I'm Sheldon Varco, Manager International Projects here at Austmine, and I'm pleased to be joined today by Fabien Trotte of CNRT Nickel and Son Environment and Julien Lombard of Prony Resources to explore new opportunities through Austmine's Global Mining Challenge program. I'll introduce you to Fabien and Julien a little later in the session, but before we begin, I would like to acknowledge that I'm hosting this webinar from the lands of the Guringai people. I also acknowledge the traditional custodians of the various lands on which you all work today and the Aboriginal and Torres Strait Islander people attending this webinar. For today's webinar, we will look at an overview of the Global Mining Challenge program and also some information about the New Caledonia nickel sector. Fabien and Julien will then provide you with important details on the supply opportunities and technical challenges currently open in the market. And then I'll step you through the submission process and schedule for applying to these challenges. Following the presentations, there will be an opportunity for audience Q&A. You can use the Q&A button at the bottom of your screen to send your questions through at any time. And you can also upvote on other questions that you most want answered. I do encourage you to use this opportunity to ask questions to get more information about the challenges. The supply opportunities discussed today, next slide please, have been developed through Austmine's Global Mining Challenge program. This is an exciting new initiative funded by the Australian Government Department of Industry, Science and Resources, and it aims at establishing collaboration between mining companies and met suppliers to jointly develop innovative supply chain solutions. Working with mining partners in New Caledonia, Peru and other markets, Austmine will utilise our innovation framework to fast-track technology development and provide an opportunity for Australian METS companies to solve critical challenges globally. I'll provide further details at the end of this webinar about how this process works. Next slide, please. Also, before we begin today, for those who aren't familiar with Austmine, we are Australia's National Industry Association for the Mining Equipment, Technology and Services, or METS sector. We aim to drive the sustainability of our industry through championing technology advancement and facilitating collaboration within our network. With over 670 corporate members nationally, Austmine promotes the METS sector around the world and hosts a range of networking opportunities domestically. So if you aren't yet a member, please make sure to have a conversation with one of our teams soon. Next slide, please. Now, before I introduce our guest speakers to explore the supply opportunities, why have we chosen New Caledonia as a partner for this initiative? Well, Austmine has been engaging with mining organisations and partners in New Caledonia for over a decade now. And more recently, we have seen a growing appetite to explore the technological solutions coming from Australia. While New Caledonia is home to major mining players and operations, productivity, energy and climate challenges have impacted production over the years. Development of new technologies and processes is required to overcome some of these challenges, and this provides a great platform for METS companies to work collectively with New Caledonian mining and industrial companies to boost performance and take us to a sustainable future. We look forward to taking our relationship with our Pacific neighbours to new heights with this project. Next slide, please. So now on to the supply opportunities that we'll be discussing today. So first, I'd like to introduce Fabien Trotte, who will present the first supply opportunity. Fabien is the Managing Director of CNRT Nickel and Son Environment, which is an industry group that represents the major nickel mining companies of New Caledonia. CNRT promote the sustainable development of the industry, and he will discuss the joint challenge faced by local producers to reduce the moisture content of nickel oxide ore. Fabien is also joined online by some mining representatives of their group, and they will take part in the audience Q&A. So please make the most of this opportunity. Welcome, Fabien.
Thank you, Sheldon. Thank you. Hi, everybody. Thank you to Austmine for this opportunity for CNRT to present this challenge today. As you said, Sheldon, so CNRT is a consortium of industrial bodies and also research and institution of New Caledonia. we are supporting the competitiveness of the nickel sector in New Caledonia. And as you may know, in terms of world nickel producers, New Caledonia is the fourth country in terms of production, and in terms of value of the nickel production, is probably the second top world countries. So there is a big challenge for us and for the mining companies supporting and members of CNRT, which are listed on this slide. Pretty much nearly all of the mining and metallurgical companies of New Caledonia are supporting this challenge we are presenting today. The next slides, please. So, and next and first illustration, please. So the problem with we have with the moisture content of the nickel is that, as you can see on some of the picture we are presenting here, the moisture gives the ore a sticky and clogging properties, which will impact all the downstream processes of the industry. So it means not only the handling and the transport of the ore, but also pretty much the grinding, I would say the performance of grinding and sorting of the ore, which consequently impacts the overall mine performance, but also in terms of quality, that will impact the ability to recover the reserve at mine site, so the lifetime of the mine, and not only the operating costs. Further down, we have impacts on the loading rates. Next illustration, please. So as we can see here, we can impact the ability to recover the ore. You can see on the picture on the right, but also all the sampling facilities. This is the up left picture with that kind of clogging we currently have in the installation. And the next illustration, please. Then going down to the installation for loading the ore, we can see the sticky and high moisture aspect of the ore. And on the right picture, you can see the liquefaction we sometimes have on sites, which rises the probably the biggest risk in terms of ability to ship the ore, with problem like liquefaction in the hull, which has dramatic consequences, as you may know. Then further down to going to the metallurgy aspects, the ore coming at the plant, we have issues with homogenization and drying, so it impacts not only the performance of the process, but the overall cost. I would say the energy which is necessary to go through the steps of the process, but also not only energy itself, but also the CO2 emissions. And regarding all the aspects we're facing with the global the global change in terms of climate, all those problems we have are going to be increased. So we need to face those problems, and that's the purpose of the challenge. Going to the next slide, please. So here on the top of this slide, I just put some of the issues we went through previously. I would just in this slide focus on what kind of trials we already did on sites to deal with this problem of the moisture of the ore. We can see on the top right what is commonly done in terms of exposure to natural sun in order to prevent from getting more humidity, and then to help with the evaporation. Then we go on layer stockpiling, and we, depending on mine sites, use either tarp or roof solution in order to prevent additional moisture coming back from rains in tropical conditions. More recently, we also worked on polymers, but anyway, all of those solutions we emphasize here only contribute to limit additional moisture in the ore, but not effectively to reduce the moisture content of the ore. So regarding all the operation costs we have for those kind of trials, the question is that how to deal further in terms of not only preventing from the moisture increase, but also going more further to a decrease of the moisture content of the ore, and what kind of technology we can have to face this challenge. Into the next and last slide, please. So the solution we are seeking in terms of support is to reduce the water content and the moisture of the ore. We are seeking a range of solutions that can be more or less a combo of different solutions, depending on their own effectiveness, depending on I would say the performance and the constraint in terms of operating on industrial conditions. And we are open to a range of solutions that could help to reduce in step by step the ranges of moisture from 1 to 5%, or 5 to 10%, or greater than 10%, depending on the solution you can propose for these targets. Among the requirements, we would like the solution to have a positive balance in terms of energy compared to what we operate at the moment. And we must focus on energy supply that would come from renewable for that kind of solution. Also, at this step, we focus on solutions that would be implementable at mine site. We don't want the solution to be implemented at the plant in terms of metallurgy, I mean. So it's mostly the mine site operations, the mine site itself, either, or the site for with the loading installation. And we need the solution to be respectful of the mineralogy of the ore. That means that we don't want to move on that kind of calcination that would be more a pre-metallurgical part of the process. So the solution we are seeking might be respectful of the mineralogy of the ore, which is also critical for the clients that our members have down the process. So we're pretty much at the end of this presentation. I will appreciate the question. We also have in the team some of the members of CNRT that can help also to answer your questions. Thank you, everybody.
Fantastic. Thanks a lot for that, Fabian. And it's been great working with the CNRT consortium thus far, and we're looking forward to seeing some solutions coming through for this challenge. I'll just add as well that this is, as Fabian mentioned, it is quite a broad challenge, and it could have multiple solutions, working in parallel to solve this. So, and also it is also a problem that's not just unique to New Caledonia. It is relevant to other nickel markets around the globe. So finding a solution is very important for an industry that's critical to the future, and also could be quite lucrative for the solution providers that can come up with a solution. So do use this opportunity to ask some more questions to Fabian and the team, and we look forward to seeing some of those solutions coming through. So thanks a lot for that, Fabian, and we'll hear from you in the Q&A. Moving on now, I'd like to hand over to Julien Lombard, who's the Sector Manager Process Technology at Pronia Resources. He's going to discuss two supply opportunities emerging from their Goral, nickel and cobalt operations in the south of the island. And Julien will be looking at reducing gypsum scaling and also reducing the scaling rate in the HPAL autoclave. So I'll hand over to you now, Julien. Thanks very much.
Thank you, Sheldon. Hello, everybody. Thanks again to Austmine to let us the opportunity to present these challenges. So I will start with a quick presentation of our process, because I think it's a good start to understand the two topics that we will discuss after that. So as said in the introduction, we process laterite and saprolite ore in our plant. So we feed a mix of these two kind of ore to the plant as a slurry. We thicken the slurry and we feed this slurry to our ash pile process. So we have extreme condition in our ash pile process. We are at 260 degrees in the ash pile, so in the autoclave, so very extreme conditions. We will do the leaching, adding sulfuric acid in the autoclave to dissolve the nickel and cobalt and all the other impurities. After that, we have a step of separation of the liquid and the residue of the autoclave, the solid residue of the autoclave. And then we feed the liquid solution, the PLS, the pregnant solution, to a step of neutralization. We neutralize with limestone in the first step and then with lime. And after that, we arrive to the last part of the process where we will precipitate our final product as MHP using magnesia in the process. After that, we have a lot of solid residue coming from this process, mainly residue from the leaching. So we have a residue of hematite and alunite, and it's a mix with the gypsum created during the neutralization process. And all this solid is sent to a pond that you can see on the first picture. This slide will settle in this big pond, and after that we pump back the liquid on the plant to treat it and to pump it to the ocean. It's our liquid effluent that we pump to the ocean after the treatment on the plant. So that allow me to introduce the first topic, the first challenge that we want to discuss here. So the first one is that as we want to treat this liquid effluent, we use lime to do the neutralization and the precipitation of the last elements that we have in the solution before being able to pump it to the ocean. So the last element are the manganese. The main one is the manganese, and we need to target concentration under 1 ppm of manganese. So to do that, we need to use a lot of lime to precipitate the manganese. And doing that, we saturate a lot our effluent with calcium. After that, the effluent is pumped to the ocean in a big pipe. So we have a part of this pipe which is onshore, which is 5 kilometers onshore. And after that, the pipe go in the sea, and we have 20 kilometers of pipe under the sea to go to the effluent outfall where it's released in the ocean. The issue is that with this saturation of calcium, we have a desaturation finally of the calcium in the effluent pipe, and it desaturate, precipitating as gypsum in the effluent, in the pipe. So finally, a part of this gypsum will go through the pipe and goes to the outfall, so it's not a problem, but part of this gypsum will also precipitate on the wall of the pipe. We precipitate on the pipe. It's a small part of the gypsum, but it can create a thin layer around until 3 millimeters of thickness of gypsum. And because of that, we have a loss of pressure in the pipe, and it reduces a lot the flow that we can pump in this pipe. We really need the maximum flow of pumping in this pipe to be allowed to empty and to evacuate all the liquid effluents that we have on the plant. that's why we want to present this challenge. It's because we are looking for a solution to tackle this issue. So it can be something like avoiding the precipitation of the gypsum on the pipe, or something like a method to descale finally the pipe when it's already scaled, when we already have the thickness of gypsum. Maybe we can go to the next slide, please. Perfect. So here you have a picture of the pipe on the right. So that's the N 700 pipes. And here you can see just a little bit of scaling in the pipe. So that's just an example of what we have. It's a very thin thickness, but it's enough to be a problem and to reduce the flow a lot. So as I said, two kind of solutions are expected. So the first one is avoiding the precipitation, avoiding the precipitation on the pipe. And the second one is a method to descale. So it can be a mechanical method or other. But we have a big constraint at this point, because it's a very delicate topic. As we send this effluent to the ocean, we really need to be very careful on what we do in this effluent, and what if we want, for example, to add some products to avoid precipitation or to remove the scale. We really need to be sure that this product is okay with the release in the environment. That's why that will be the most difficult part, I think, of this challenge. Is just to be sure that we keep the right to send this effluent to the ocean. So as I said about the solution, we really need for sure to keep the safety around this operation. So it's normal. We have to keep the effluent quality. As I said, we need to stay in the limits that we currently have in terms of the different elements that we have in the solution. And if we add new element to the effluent, we really need to be sure that it's okay to release this kind of thing in the ocean. And if it's a mechanical thing, there will be, I guess, costs. And as we know, it's the current world situation is complicated and all the costs are very high. So we need to be careful about the cost also. So I think I'm done with this topic. So maybe we can go to the next one. Yes, perfect, please. So the second topic is it's about scaling too, but this time it's more scaling of hematite and alunite. As I said during the introduction, we have a process of HPAL where we feed the ore, the slurry of ore in the HPAL, in the autoclave. We add the sulfuric acid to do the leaching. And during this process, we have a precipitation of hematite, the iron precipitate as hematite, and the alumina precipitate as alunite in the autoclave. So the most important part of this precipitation stay in the solution as a slurry and leave the autoclave at the end of the process, the HPAL process. But part of this precipitation is done on the walls and on all the parts of the autoclave. So you can see on the picture there that you have precipitation on an agitator. You have precipitation on the walls that you can see on the second picture on the bottom. So the issue is that it's, I think, clear enough. But when you have precipitation on the shaft and on the agitator, you decrease your efficiency of agitation. And when you precipitate on the walls, you decrease the residence time in the autoclave, and you can create some plug of your autoclave. As we have 6 compartments in the autoclave, and we go from one to another one by overflowing. So if you have too much scale, you can have some issue of plugging. So this kind of crust of scales can be very thick, especially in the first compartment where we had the sulfuric acid. So we create thick scales that can go to 15 centimeters in the worst case in the first compartment. So that's begin to be a huge scales, and it reduces a lot the residence time and the agitator efficiency. We try to understand better what happened really about these scales, because in the design of the plant it was not forecast to be that important. And finally we have a different ore compared to what we should have if we compare to the design. So that explains a lot why we have these scales. So now we have to find the solution to reduce this scaling rate, which is very important, or to be able finally to measure the thickness of the scales, because we have to stop the autoclave after a certain number of days of operation without knowing what is the thickness of the scale. But with experience, we know that after 120, 140 days of operation, we decrease a lot the efficiency in the autoclave because of the scales. So usually we stop one autoclave after this time just to do the maintenance and remove all the scales. But sometimes we had the surprise to see that finally the thickness of the scale were not that high, was not that thick, and finally we would have been able to run longer time the autoclave. That's why if we have a method just to measure the thickness of the crust of the scales in the autoclave, it could be a first solution, because we will be able to know when we really have to stop an autoclave for maintenance and maybe gain some days of production, which is very interesting. The other part is if we have a solution to finally reduce the scaling rate, or maybe spread the scaling in the autoclave in the other compartment, that would be very interesting. Can we go to the next slide, please? So here you have some examples of the crust that we have in the autoclave. That's hematite and alunite, as I said. So it's a really hard crust, very hard scales that we have. We need to remove it by water pressure. It's high pressure, and it's very hard to remove. But finally, if we can just reduce the thickness of these scales, or just again being able to measure it during the operation, that will be a very good option, a very good solution. Due to the extreme condition in the autoclave, we didn't find this way to measure the thickness yet, but that's why we are here, and hoping that you will have a solution for that. So of course, we don't want to decrease the HPL performance and recovery. So we can't reduce, for example, the acid injection, reduce the acid injection or acid dosage finally, just to be sure that we don't precipitate the hematite or things like this. So we need to keep the same performance in the autoclave. We can't do very big changes like changing the acid, the type of acid, or this kind of thing. We can't really change the ore. The feed is what it is and what we have on the mine. So finally, we can't really play on this part, and we have to keep the same safety requirements that we already have on the autoclave. For sure, we can't play on this point. So I think I'm done with this presentation. I'm hoping that you will have many questions for me. Thank you.
Fantastic. Thanks a lot for that, Julian. Some good opportunities there, and it's probably a good demonstration of the type of environments you encounter in New Caledonia process plants. It's quite harsh and corrosive environments a lot of the time. So I hope this provides good scope for some solutions to come through, and we look forward to working with the team at Prony Resources. We do have some questions coming through, and you can see those in the Q&A box. So please continue to send those through. We will get to the Q&A session shortly, but just before that, I'll just take everyone through the submission process and the schedule for these challenges. So the Global Mining Challenge is designed to identify and develop solutions in quite a quick open innovation process. So from the challenge being published to a final a winning solution being chosen, it usually goes no longer than 10 to 14 weeks. In phase one, so it's rolled out in 3 phases. In phase one, Austmine invites interested suppliers to submit a short form proposal, which provides general details of the conceptual solution for the challenge. The submission form is quite short and only takes about 15 minutes maximum to complete. And a link to each of these challenges can be found on the Austmine website, and these are open now to submit. Following the submission deadline, which is currently scheduled for the 10th of February, Austmine and our partners will review the short form proposals and will shortlist a range of companies to move to phase 2 of the process. So at that stage, all successful and unsuccessful companies will receive a communication from Austmine regarding their submission to conclude phase 1 of the challenge. Next slide, please. Oh, yeah, sorry, this slide, thank you. In phase 2, the shortlisted companies are invited to a technical workshop with the mining partners. And this is really with the aim of gaining more information about the challenge and then participating in Q&A. So this is where you might receive some more data and information to help you out with updating a solution proposal. We then move to the pitching sessions, which allows companies to have 10 minutes to present their solution to the miners and gain direct feedback about their proposal. And at this point, the pitches are reviewed and a final group of companies are selected to progress to the final phase of the challenge. Now, how many companies really depends on how many submissions and the quality of submissions that we receive. It could be a handful, it could be 10 to 15. It just depends on what we receive from the challenge. Next slide, please. So in the final phase, in phase 3, the shortlisted companies are invited to provide a more detailed technical and economic proposal for the challenge. This will outline how the solution will be implemented, expected timelines, estimated costs and resources required. These proposals are reviewed by the mining companies, and a winning solution or multiple solutions could be selected. And then these companies then engage directly with the mining partners to finalize terms and progress to what might be a pilot project or technology implementation. So that phase is then a direct engagement between the mining organization and the selected supplier. Next slide, please. So the New Caledonia challenges, as I mentioned, they're currently open for your short form solution submissions until the 10th of February. So this allows another 3 weeks or so to put forward your ideas and concepts. The subsequent phases are then expected to take place throughout February and March. But please note that timelines do sometimes vary depending on the responses we receive and also the bandwidth of our partners with the challenges. So with that in mind, I hope that clarifies the process. We will now move on to the audience Q&A part of the session. So I will open up the floor now for questions, and I noticed that Fabian has sent some some answers through via text, but I will also open up those questions so we can hear them over the line. I might start with this one for you, Julien. So is it possible to share a diagram or presentation of the Peroni Resources metallurgical process?
Yes, sure. How do you want to do that? If you send me your email, I can send you a diagram.
Yeah, if that's Julien, if that's an open resource, we can always share that in the webinar follow-up email as well. So if that suits you. To
share it now, you mean?
Oh, no, to share it in follow-up to this webinar.
Yeah,
we can share
okay.
it with all of the participants.
Yep. Yes.
So we'll follow
for sure.
up on that point.
Yep.
Excellent. Fabian, I might come to you on this question. So, are the CNRT companies looking for the same solution or different solutions for different companies?
Yes, Sheldon, I just commented previously on the chat, adding some insight on this. We are not only seeking for a same solution, but depending on the ability of all the mining company in terms of investment, in terms of implementation, that might be part of same global solution, but at least all of the companies agrees on the problem and issues we have. So it means that the global solution would be appropriate for most of them, and then it's just a question of implementation rate, etc. But to be best effective, in this approach, if we keep it most modular in terms of moisture reduction target, that would be perfect to allow all the combination and possibility to us to address.
Perfect. And I might follow up with this question, which you did cover towards the end of your presentation, but the question is, where would the ideal solution be in the mining process? So if you could just elaborate on that as well, please.
Yes, so the main two steps at which we have the issues would be the beneficiation and all the sampling of the production we have at this step. And then the last one would be the stockpiling operations. So that means that depending on the ability of the solution, the amount of material we can put it in terms of industrial mode, it would be either upstream or downstream of those steps that we would see the solution. So it means it can be on the mine, either on the mine side or at the loading site installation. Perfect.
Excellent. Julian, I might come back to you for some questions regarding the basically regarding the HPAL descaling process. So Ramiro asks, how long does it take to descale or remove the crust formation, and what is the downtime associated with this problem?
It depends a lot on the thickness of the crust and the repartition in all the compartment of the autoclave, but usually it's between 1 and 3 days to remove all the scale, to destroy them with high pressure water, and then to remove them from the autoclave.
Okay, excellent. And I guess a similar question as well. So please advise the turnaround time for the HPAL autoclave at the 3 monthly shutdowns.
I'm not sure to understand what is the difference with the.
Yeah, so I guess it's the same as what you've answered there. So it depends.
Depends.
Yeah.
Yeah, exactly.
Yeah. Excellent. So Mauricio asks regarding the gypsum scaling, can you please confirm pipe ID and flow rate?
So it's a HDP pipe. It's a GAIN 700, and the flow rate currently it's 2,500 cubic meters, and we really want to go until 3,000 cubic meters.
Excellent. Regarding the HPAL autoclave, what are the key performance indicators that could allow you to extrapolate that there is a buildup of scaling?
That's the point. We don't have a lot.
Yeah.
We can see a reduction of the recovery, but when we are really scaled, we have a reduction of the recovery because the residence time decrease a little bit, and we have to compensate using more acid or things like that. So finally, that's one of the points that can say that we are too plugged, and sometimes the scale we can see that we have some issue going from the first compartment to the second one, showing that we have almost a plug in the autoclave. So we have these two things, but finally, if we can find other parameters saying that we have too much crust and too much scales in the autoclave, that's the point of this challenge. That's what we are looking for.
Excellent. We have another question here around a flow sheet of the process. So that's what I guess we covered in some additional information that we can share after the webinar. So I will, Julian and I will talk after this webinar and we can share something in follow-up with all of the attendees so to answer that question. Still sticking on the autoclave challenge. So is the autoclave feed chemistry well understood so far as enabling scale development, or is there scope for blending upstream?
So we have a lot of information from the pilot of the plant. So we did a lot of studies this last year. So we understand a lot what impact the scaling rates and for example the alumina or things like this. And currently we have another study with we go through a thesis with a French school, and we have a thesis ongoing to better understand what are the different reactions in the different condition of the autoclave and to understand more the condition. We have a lot of information and knowledge, but finally we know that we can't really play on the feed of the autoclave to reduce the scale. So we have to change something, but we can't really play on the ore concentration or things like this. We have to do with what the mine provide to the autoclave. But we have a lot of information that we will be happy to share, I think, if you want. But with what we know, it's difficult to do something as we can't really change the ore feed.
Excellent. And just finally on the autoclave, a bit of more of a simple one to answer, Julian. So what diameter is the autoclave?
Sorry, I didn't hear.
What diameter is the autoclave was the question.
I don't have it in mind. I can tell it after if you want.
Yes, perfect. We can follow up with that information.
Yeah.
So Fabian, on the nickel moisture challenge. So how do you quantify or measure the proposed improvements? Is there scope for a measurement solution combined with the large scale improvement project?
Yeah, I would say that among the key KPI we would have to document this, it would be the performance rate of the installation and the production we have at the critical stages we mentioned before. With respect to the moisture monitoring of the moisture reduction in the ore on a current basis, and this has to be reconciliated with the energy consumption of the solution and the ability to maintain the solution. So I would say the main production parameters compared to the key question regarding the cost and ability to implement in this solution in terms of compatibility with the processes we currently have on mine site at the moment.
Excellent. And following up on that, Fabian, another question on the moisture challenge. So regarding dewatering, what do you mean by polymer stabilization?
Okay, I don't see the one regarding the polymer. I just catch the one regarding the moisture content. So can you please?
Yeah, no worries. It's just it's in the answered section, but the question is regarding dewatering. What do you mean by polymer stabilization? That's the
We're trying at the moment some kind of solution which is using a polymer that would fix the water content in the ore, which prevents the water to be free and that can stabilize the amount of water in. So that's just among the trials we have at the moment. That's not necessarily definitive solution, that would really be effective to reduce the moisture of the ore. I don't know if any additional information regarding this.
Excellent. No worries. I hope if that doesn't answer the question, please just submit another question and we can elaborate on that. A question from Jin following up on that, and this might depend on each mining company, but he does ask, what is the moisture content target for your end product?
Yeah, we at the moment don't have a specific target in terms of clients for the production, but the most important target is to reduce by zero the issues we have in terms of stops in the production due to clogging aspects of the ore or due to inappropriate conditions regarding the transportability of the ore. As you may know, we have a test which states if there is a liquefaction risk for our ore. This test is sometimes critical, so that means reaching the situation in which we can load the ship without any stop due to the moisture content. That would be the first target. Then we can have additional targets. So in terms of moisture reduction, that would be decreased by more than 5%, and then more by 10%. The other target would be more the some kind of economic competitiveness target. So the second target after the production is effectively done in appropriate and good conditions, if we further decrease the moisture, we add more value to the ore. So that would be the second target we have in this challenge.
Excellent. Thanks for that, Fabien. The question here that I can address. So would you please provide the link for EOI submissions forms? Yes, no problems. We can put that in the chat box, and that will also be provided to everyone with a follow-up email after this webinar as well. So that's no problems at all. We're coming towards the last few questions. So if you do have any more questions in the audience, please send those through now. Question here for you, Julien, regarding the gypsum scaling. So are there access points on the subsea pipe?
Unfortunately, no, because the pipe goes down very fast to 40 to 50 meters under the surface. So after that, you don't have any access finally. If you need to do an inspection, you can send divers, but scuba divers, but it's a lot of organization, and you have to stop the process to do the inspection. So no, it's not easy. We don't have any easy access to the inside of the pipe.
Great. And one more question for you, Julie. I'm not sure which challenge this relates to, but is the main reason for the lime addition to precipitate Mn? Was Mn at 1 ppm? And what is the pH before the lime addition? So some technical questions there about the process.
Yeah, that's for the gypsum challenge. So we add the lime because we have the lime finally. That's the one of the reagent we have on the plant. In the past, we used to use SO2 with lime to have a better selectivity on the manganese and precipitate mainly the manganese. But now we have to use, for a technical reason and reliability reason, we have to use only lime, and that's why we saturate more than before the effluent. The pH before the lime addition is about 6.5 to 7, and we increase a little bit with the lime addition to precipitate the manganese to be under 1 ppm. Before the lime addition, we are around 50 ppm, I think, something like this.
Okay, excellent. And a follow-up question on the gypsum challenge. So have you tested various pipe linings over the duration of this issue?
No, not yet.
And is
that could be a solution.
Okay, so that's part of the scope of this challenge, is that it could be a different pipelining.
Yeah, but I guess it's very expensive to do that. But yeah, that could be a solution that need to be studied. Yeah.
Perfect. So I hope that helps you out there, Jim. There's a question here that I can provide some feedback on. So are we to provide budget for proposals and how much funding can we plan for? So in terms of the original proposals, short form proposals, no need to provide a budget or anything in the first instance. And at the end of the phase 3, if you make it to phase 3, the final challenges, that's when you will submit a full proposal which has some of that information, and where you'll directly engage with the mining companies regarding what a pilot test might look like. Just to check, was there any other comments from the other panelists on that question? No. And coming to the final question here that I have. So if the main objective of CNRT companies is improved handling and optimal ore conditions for processing, is there any value to be attributed to water recovery, i.e. for reuse in downstream processing, or stabilization / removal or reduction target? Is the sole benefit to consider?
Thank you, Sheldon. So we definitely need to consider the ability to recover the water in the downstream in the process, but until now, it is just a consequence of the process we would implement. So we need to consider this question indeed. I also want to emphasize that it's not needed at the beneficiation stage that we need to implement. It is definitely also for the loading facility and the shipments that we need to add a solution. And finally, we have a last comment of a colleague of CNRT on the question of energy, and I would like to give the opportunity to my colleague Sebastian to take the to add some comment if he can has his microphone on.
Can you hear me?
Yes. Yes.
Yep.
Oh, good. Okay. Hello, everybody. Yes, I just wanted to add a point about the energy consumption downstream, not only speaking of material handling on mine. And I would say that this is a really important energy consumption to dry the ore. Just an order of magnitude, if you consider 1 point of humidity, of moisture, it's roughly more or less equivalent to 10,000 tons of CO2 per year from our side. So this is really huge. It's more or less 15% of our emission, total emission. So I wanted to emphasize on that point and to remind that we will have a lot of improvements on mines, but also in the plant, because we have a lot of conveyors, thanks to the improvement of handling. But I want also to say, don't forget the energy improvement for each point of humidity that we remove from the ore. This is what I wanted to add.
Excellent. Thanks, Sebastian. And just so the audience knows, where were you, what business were you with, and what was your role, sorry?
Yes, I'm Sebastian Jolivet, decarbonization manager of SLN.
Perfect. Excellent. Thanks for that, Sebastian. And if anyone has more questions regarding the environmental and decarbonisation goals of the challenge as well, we can always address those to Sebastian in follow-up too. So thanks a lot for that. That looks like that's all the questions that we have, and that is quite good timing as we're coming towards the end of the session. So thanks a lot for that interactive audience Q&A. I have put the link to the challenge pages up in the chat box. So we do eagerly await those solutions coming through. As mentioned, the deadline for these challenges is currently set at the 10th of February. So please, if you have any questions in the meantime, please do touch base with Austmine. Just finally, if we can go to the next slide, please. I did mention at the start of the webinar that Austmine is working with various markets on the Global Mining Challenge. And we'll be hosting a webinar on the Thursday, the 2nd of February regarding opportunities in the Peruvian mining market, where we'll be joined by Goldfields, Nexa Resources and Poderosa Mining Company. We'll be exploring 5 challenges there. So this includes fleet decarbonisation, processing low-grade gold ore, reusing waste from the mining process, and predicting zinc production outcomes. So some more challenges there to engage with, and we do look forward to seeing you on the 2nd. You can register via our website for that webinar now. Next slide, please. As mentioned, please, if you have any questions regarding the process or the Global Mining Challenge, don't hesitate to get in touch with our international team. So we have Robert Trebsky there, the Director of International Business, myself, and also our recent addition, Jolene James, who's our Coordinator of International Projects. And Jolene's done a great job in facilitating this webinar today as well. Next slide, please. So once again, thanks to everyone who's attended today, and we hope that you've found some valuable insights into these supply opportunities. Final reminder that the closing date for short form proposals is 10th of February. And a big thank you to our friends in New Caledonia for partnering with Austmine on this initiative. So a big thank you to Fabian and Julian for joining us, and also the overall CNRT consortium as well for working with us. So once again, everyone, thanks for attending, and we'll see you at the next Austmine webinar. Thanks.
Thank you, everybody. Bye.
Thanks a lot. See you.